Section 5.4, this is about half angle formulas. So what we did before, when we started this, we just talked about the standard sine, cosine, tan, cotan functions. Then we did last time, we did double angle formulas. And today we're doing half angle formulas. So the question is, what would be if there is any formula for sine alpha over 2? What about cosine alpha over 2? Now, as you know, as soon as we get these two, we can get the rest in a so easy way. So is there a formula for these two functions? Well, let's see. What we learned last time, we learned 3 formulas for cosine 2 alpha. Let's start with the first one, recalling the first one. That was the first one. 2 cosine square minus 1. 2 cosine square alpha minus 1. What I'm going to do, I'm going to derive a formula for the cosine alpha over 2. I can add 1 to both sides of this equation. And I'm going to rewrite it. So if this equals that, it's the same thing as if you do 2 cosine alpha equals 1 plus cosine 2 alpha. So if A equals B, B equals A. Then I'm going to divide both sides by 2. To give me 1 plus cosine 2 alpha divided by 2. And then cosine alpha from here by the square root property is plus or minus the square root of this whole quantity. But I need to find a formula for cosine alpha over 2. So this is what we're allowed to do. When we write cosine, never just write cosine. You have to follow up with that with something. That number that between the parentheses is the angle. If I look throughout the entire equation, I see another angle here, 2 alpha. We are allowed to multiply or divide these numbers by any number we like, these angles by any number we like, except 0, of course. So we can divide by 0. So what are we going to do here? I'm going to divide the alpha by 2, as you can see. And since I did it here, I'm going to divide the 2 alpha by 2. That makes it alpha. So this is the formula for cosine alpha over 2. Is there a, how do we find a formula for sine over 2? Sine alpha over 2. Well, let me go back to cosine 2 alpha. There was another formula for cosine 2 alpha. Is this one. 1 minus 2 sine square alpha. I'm going to solve for sine square by adding, so kind of like adding this to the right side, left side, and then this to the other side. So it's 2 sine square alpha. Keep the one the same, minus cosine 2 alpha. Divide everything by 2. So sine square alpha is 1 minus cosine 2 alpha divided by 2. So then sine alpha is plus or minus the square root of 1 minus cosine 2 alpha over 2. Again, we can divide the angles that I'm going to highlight by 2. So that gives us sine alpha over 2 to equal plus or minus the square root of 1 minus cosine alpha divided by 2. These are the formulas for sine and cosine. So how do we apply them? Let's say we are asked to find the value or the exact value of cosine 22.5 by hand. So you can't use calculators. So how do you do that? Well, to start with this one, if I think about this as alpha over 2, so, and multiply both sides by 2, that gives me 45. So now I want to find what this is going to be. To do so, I'm going to use the formula for cosine. Here you go, cosine alpha over 2, cosine alpha over 2 is plus or minus the square root of 1 plus cosine alpha, all divided by 2. Now notice I'm finding cosine 22.5. The 22.5 is somewhere here in the first quadrant. So in the first quadrant, everything should be positive. So cosine 22.5. See, if you match them, as I said, This means alpha over 2 is 22.5. And this means alpha is 45. So cosine 45 over 2. And notice I only chose the positive one because it's in the first quadrant. Now, we are familiar from previous sections with cosine 45, which is square root of 2 over 2. All that divided by 2. And now what we do now, this is over 1, this is over 1. We multiply the top of each one by 2. And let's see what we get. This stays the same. This is 2 plus square root of 2 over 4. And notice this can be written as the square root of the top, square root of the denominator, which is 2. So that gives me what I need. No need for calculator. You don't have to put that in the calculator either. Just you stop there. That's the answer. Another example, find the value or the exact value of sine 15 degrees. Sine 15 degrees. So how do you find that out? We need to find the sine 15 degrees. So think about this. You know, that reminds me of sine alpha over 2. It's plus or minus the square root of 1 minus cosine alpha all over 2. So if you want to find sine 15 degrees, if you convert this to this, that tells us alpha over 2 is 15. Multiply both sides by 2. Alpha is 30. So 15 degrees is also in the first quadrant. So its sine is also positive. So this is 1 minus cosine 30 degrees all over 2. So we get sine 15 degrees equals 1 minus cosine 30 degrees from previous sections is radical 3 over 2, all over 2. This is over 1. LCD is 2, multiply by 2, by 2, and by 2. So what do we get? We get sine 15 degrees equals 2 minus square root of 3 over 4. You can rewrite this as 2 minus square root of 3 over square root of 4, which is 2. That's exactly what we need. That's the answer. Now, what about a different application? If, let's say, sine x equals 12 over 13 with x in quadrant 2, we need to find sine x over 2 as part A. Part B, cosine x over 2. And C, tangent x over 2. So, how do we do so? Well, the first thing is, what is the formula for cosine or for sine? What we need. So, this one has a formula. It's a plus or minus the square root of 1 minus cosine x over 2. This has a formula plus or minus the square root of 1 plus cosine x over 2. So it seems like to find them, I need cosine x. So from sine x, how do I find cosine x? Well, we can here draw a triangle. This is x. So I'm using the Pythagorean identity here. Sine opposite over the hypotenuse, so this is 5. 5, 12, 13, Pythagorean triple, very important. So from there, we can find what we need. So what do we need here? Plus or minus the square root of 1 minus cosine is the adjacent over the hypotenuse. All divided by 2. So some people like to combine the top ones and then do the division by 2. Or you can go straight forward. This is over 1 over 1. And multiply each fraction, the top of each, by 13. That gives me plus or minus the square root of 13 minus 5 over 26. this equals plus or minus. On the top we get 8 divided by 26, which can be reduced as 4 over 13. And this gives us plus or minus the square root of 4 over the square root of 13. And then you can rationalize if you like to do so. Now back to this, is it a plus or minus, or we don't know? Well, they tell us x in the first quadrant, second quadrant. So this means I'm gonna write this here, x between 90 and 180. That's what second quadrant means. 90 degrees and 180 degrees. But I'm finding x over 2. This is what I'm finding, x over 2, x over 2, x over 2. So where is x over 2 located? One thing you can do, you can divide this entire inequality by 2. 90 divided by 2, 45. X over 2. 180 divided by 2 is 90. So this means now we are in the first quadrant. That's why sine, cosine, tan, cotan, all of them are going to be positive. So I can simply get rid of the negative signs. Get rid of the negative sign. So it's only positive. Same thing here, no need for negative. And now we go through the calculation for this one the same way as we did the other one. 1 plus cosine was 5 over 13 all over 2. Again, least common denominator is 13, so multiply this by 13, multiply this by 13, this by 13. So what do we get here? We get 13 plus 5 over 26. That gives us 18 over 26. I like to show this step by step. So we can reduce by 2, 4 by 2, 13. The square root of 4 is 2 and square root of 13 is 13. Oh, wait. 9. This is 9, so that's 3. So 3 over the square root of 13. Now how do we find tan x over 2? You didn't give us a formula for that yet. But wait, we can define this using the quotient formula as sine over cosine. And we found both of them. The first one was 2 over the square root of 13. The other one was 3 over square root of 13. These cancel out. And the answer simplifies down to 2/3. Can we find secant? Yes, we can. And cosecant? Yes, we can. So C or D, secant x over 2, E cosecant x over 2. What is secant? Secant is 1 over cosine. And cosine x over 2, we found it. It was 3 over, so you do the reciprocal of 3 over root 13, which is root 13 over 3. This one is 1 over sine x over 2. So 1 over 2 over square root of 13. So that gives us square root of 13 over 2. So now the next question students ask, what is it a formula actually for tangent x over 2? And the answer is yes, there are two formulas. Two formulas. How do we get them? Well, this is what we can do. If you go back to the original, these boxed formulas, this cosine and sine, and I'm not going to do it now, but if you divide them by each other, you divide them, the twos will cancel each other, the plus or minus will cancel, and then you can do what we call rationalizing. And then after you rationalize and simplify, you will get a formula for tangent. So tangent x over 2 or alpha over 2, the formula is 1 minus cosine alpha over sine alpha. And if you rationalize again, you get another formula, sine alpha over 1 plus cosine alpha. These are the formulas for tan alpha over 2. How do we apply it? Find the value, or the exact value, of tangent 112.5 degrees. What is the value for this? So tangent 112.5 degrees. equals, let's say I want to use, you can use either one of them. Well, first thing, wait, what is alpha here? This is, if you match this with the alpha over 2, so you match this, alpha over 2 is 112.5. Cross multiply, alpha is double this, that's 225, 225. So when we want to find, let's say I'm using the first formula, 1 minus cosine, alpha is 225 degrees over sine 225 degrees. So what's cosine 225? Let's say we forgot how to do it. Let's draw the unit circle. 225 somewhere here. This means this is 180. 225. 225 minus 180 is 45. Drop a height. This is 1. If you remember, this is 1. This is 1 over root 2. This is 1 over root 2. So the coordinates of this point here, the coordinates are negative 1 over root 2 because it's to the left of the origin. This is the origin. Comma, it's down, so negative 1 over root 2. Both sine and cosine are the same and both are negative. So that would be negative 1 over root 2, and this is negative 1 over root 2. Some people use radical 2 over 2. It's the same thing. So now if we multiply, or actually before you multiply, the two negatives, they become positive, like so. And that's over 1. And that stays the same. So you can multiply the top of each fraction by the LCD, which is square root of 2. Square root of 2. And let's see what that gives us. That gives us square root of 2 plus 1 over negative 1. So the answer is negative square root of 2 minus 1. That's the answer. We don't have to find any more, like more values of this. What else we can do in this section? Well, let's look at some identities. Every section we cover, we try to prove some identities. The first one that I have in mind, 2 tan alpha cosine square alpha over 2 is equal to sine alpha plus tangent alpha. So it's up to you to start on the left side or the right side. Doesn't matter. I'm going to start on the left side. So I'm going to rewrite it first. Keep an eye on the right side. Let's see how we do this. First thing, if you look on the right side, well, I need sine plus tangent. So for this one, what do I do with this one? Do I have a formula for that? Well, here on the right side, I'm going to write the formula for cosine alpha over 2, if you remember, plus or minus the square root of 1 plus cosine alpha over 2. That's the one that we proved today, right? But they are saying cosine square. So if you square both sides, what do you get? Cosine square alpha over 2. That will make the plus or minus to go away, and that will cancel the radical sign. That will give us 1 plus cosine alpha all over 2. So that gives me here, I can replace this with 1 plus cosine alpha all over 2, and we still have 2 tangent alpha. Since the answer has sine in it, it would be convenient to first cancel 2 with 2, to rewrite this as sine alpha over cosine alpha, because that's the only way to get sine alpha there. And keep this stuff the same. Again, I keep an eye on the right hand side. I see an addition, so that motivates me to distribute sine alpha over cosine alpha times 1 stays the same. Sine alpha over cosine alpha times cosine alpha. These cancel. Sine over cosine is tangent, and that sine stays the same. And that's what I'm looking for. That proves that identity. Next one, number 2. Prove that cosecant square alpha over 2 equals 2 secant alpha over secant alpha minus 1. Secant alpha minus 1. You can start in either one of them. Let's say I want to start with the right hand side and go down back to the left hand side. First thing comes to mind is convert this into sine and cosine. That's 1 over cosine. And this is 1 over cosine alpha again, minus 1. All these complex fractions that we have been encountering today can be cleaned up by multiplying the top of each fraction by cosine alpha, cosine alpha, cosine alpha. That's the LCD. So what do we get now? This is 2 over 1 minus cosine alpha. 1 minus cosine alpha. How am I going to get cosecant square alpha over 2? Let's say you don't know what to do next. This is what I usually do. On the scratch paper, I take that side that I'm not supposed to touch or work with and say, well, this is 1 over sine square. 1 over sine square. And I know a formula for sine alpha over 2 was a plus or minus 1 minus cosine alpha over 2 squaring. See, I do this work on the scratch. And that gives me 1 over 1 minus cosine alpha all over 2. That looks kind of like similar somehow to this one. You can mathematically rewrite this by bringing the 1 all the way down. Sorry, the 2 all the way down. So if you like to see it here, algebraic, if you have a over b, you can write this as 1 over b over a, like that. So then this matches with this. The next step would be to go kind of like backwards, to go to this one. So how am I going to do this one? This is the square of 1 minus cosine alpha over 2. Right? It's a plus or minus, it doesn't matter. And this stuff, this is basically cosine square alpha over 2. And 1 over cosine alpha over 2 is secant square alpha over 2. So that was the second example about identities. I'm going to show another example, one more example, called number 3. Let's say we are asked to prove tangent x over 2 minus cotangent x over 2 equals negative 2 cotan x. Negative 2 cotan x. So how do we do that? I'm going to start with the left-hand side. Let's see if we can get to the right-hand side. Get to the right-hand side. Let's see. The way I'm going to do this, first method, I'm going to convert things into sine and cosine. So this is sine x over 2, cosine x over 2, minus cosine x over 2 over sine x over 2. I see fractions, I can combine them, finding the common denominator. And then on the top we get sine square x over 2 minus cosine square x over 2. But what can I do in the top and the bottom? Let's recall these formulas from the previous section. We learned in the previous section that sine, the double angle formula 2 alpha, or 2x in this case, is 2 sine x cosine x. We are allowed, as I said earlier, to divide the angles by any number we like. So if I divide the angles, then I'm going to highlight the 2x, the x, and the x. If you divide each one of them by 2, so you get sine x equals 2 sine x over 2 cosine x over 2. Okay, we're going to use that in a minute. And so that's one thing to recall. The other one is cosine 2x. Cosine 2x, it's cosine square x minus sine square x from the previous section. So now how do we use this? I'm going to divide again the highlighted angles by any number I like. So I'm going to divide it by 2 cosine x, and you'll see why I'm dividing by 2 in a minute. x over 2 minus sine square x over 2. Notice this matches the numerator. So I can replace the numerator with simply cosine of x. Oh, no, it doesn't match. It's the opposite actually. So it's a negative. So if you multiply this by negative both sides, that will make it sine square x over 2 minus cosine square x over 2. So there's a negative. And then what about the denominator? Denominator matches this. There's a 2 missing. So what you can do, because there's a 2 missing, you can multiply here by 2 and the top by 2 to balance the fraction. So that 2 will stay here. And this denominator down there can be replaced with sine x. So let's keep the negative 2 down. Cosine x over sine x, it's cotangent x. And that's what the question is asking us to do. It's a lot of work, but when you do it and redo it again, it becomes easier for you. Since there was a lot of work here, what about looking at a second method? There's a second method in mind. So I'm going to start with the same side, but I'm going to use a different approach. Minus cotan x over 2. We want to prove this is negative 2 cotangent x. So how do we do that? Well, first thing, I'm going to change cotan x over 2 into 1 over tan x over 2. And what I'm going to do is, because the question has only sine in it, cotan in it, so I'm thinking about the sines and cosine. But I don't like to see half angle formulas here. I don't like to see those half angle formulas. So what I'm going to do then, if I don't need to see half angle formulas, I can replace this with the formula that we had earlier, sine x over 1 plus cosine x minus 1 over. Tangent, you can use the same formula, or you can use the other formula, 1 minus cosine x over sine x. Why did I use this one? Because watch what happens. This stays the same. The sine, this is over 1. So you can switch the division to multiplication and flip the fraction. So remember, I want cotangent or 2 cotan, negative 2 cotan. Cotan, remember, is sine over cosine. That's why I'm getting everything down there now in terms of cosine. Everything in terms of cosine. We need to make it one fraction. 1 plus cosine x times 1 minus cosine x. And what goes on the top is sine x times 1 minus cosine x minus sine x times 1 plus cosine x when we found the LCD. The denominator, if you multiply it out, you get 1 minus cosine square x. The numerator, we get sine x minus sine x cosine x minus sine x minus sine x cosine x. These cancel out. What is left in the numerator? Minus 2 copies of sine x, 2 copies of sine x cosine x. And in the denominator, I simply have 1 minus cosine square. Wait a minute, I wrote something here. Cotangent should be cosine over sine. So in the I need sine now. See, I need sine in the denominator. So instead of 1 minus cosine square, I'm gonna replace it with sine square x. 1 copy of these cancels 1 copy. The only thing left is cosine and sine. And that's exactly what I want, 2 cotan x. Identities, they become really fun if you do more and more of them. It's just like at some point you want to kind of just practice more. You want to do more to see if you can prove it or not. You feel you accomplished something. So that's what this section is about. We introduced half-angle formulas for all the 6 trigonometric functions. We saw how we use them when it comes to calculating, let's say, 22.5 degrees or 112.5 degrees. Or if they give you something like pi over 12, if you don't know where to start, always convert into degrees and you will see it makes it easier for you to work with. So that's the power about these half-angle formulas. We can find the sine and cosine and the other trig functions of any angle that you might think that can be done by hand. But these formulas help us to do so. And then they have applications in the subsequent sections.